have you ever wondered that during replication, why are primers recruited by RNA polymerase, not DNA polymerase? That means if we want to insert primer, then we need RNA polymerase. Why DNA polymerase cannot do work for the insertion of primer? So what is the reason behind it? So the main reason behind it is that the DNA polymerase activation site. DNA polymerase activation site only activate in the presence of 3' hydroxyl group that are freely available during the replication of DNA strand. If 3' hydroxyl group are not freely present during the replication process, DNA polymerase cannot do work. DNA polymerase cannot recruit the new nucleotides on the new DNA strand. So that is the main reason behind it, is the activation site of DNA polymerase that only activate in the presence of 3' hydroxyl group. If 3' hydroxyl group are absent, then DNA polymerase cannot insert the upcoming nucleotide on the new DNA strand. That is the main reason that DNA polymerase make the bond in between 3' OH group of the existing strand and with the 5' phosphate group of the incoming nucleotide. So if the activation site is activated only in the presence of 3' hydroxyl group that are freely available during the replication. If 3' hydroxyl group are not freely available, then what will happen? It's simple that if 3' hydroxyl group are absent, then no upcoming nucleotide will be inserted on the DNA strand. So for the formation of DNA strand, we need primers, and the primers will be synthesized by the primase, that we also call it RNA polymerase. So the RNA polymerase and DNA polymerase activation site difference mainly is that the RNA polymerase activation site cannot need 3' hydroxyl group for its activation. That means if 3' hydroxyl group are absent, then RNA polymerase can also recruit the upcoming nucleotide on the DNA strand. So that is the main reason. So for the formation of primer, for the formation of short RNA primer, that is about 5 to 10 nucleotide, we need RNA polymerase, not the DNA polymerase, because RNA polymerase can do its work in the absence of 3' free hydroxyl group. The main difference in between DNA and RNA polymerase is that the accuracy of DNA polymerase is higher than the RNA polymerase. That is the main reason that RNA polymerase will do its work for some time. That is, after 5 to 10 nucleotide inserted, then RNA polymerase stop to do its work, and after that RNA polymerase hand over its work to the DNA polymerase. After 3' hydroxyl group are present in the form of primers, then DNA polymerase continue to do its work, and the RNA primers after the replications are removed by DNA polymerase 1, and the gaps that are present in between the DNA strand are sealed by the DNA ligase. So here is the main difference between DNA and RNA polymerase, and for the insertion of primer we need RNA polymerase, not DNA polymerase. That is the main reason behind it, is presence of 3' hydroxyl group, and the accuracy of both the enzyme, if we see, that is DNA polymerase enzyme have more accuracy as compared to RNA polymerase. After that video, I hope you know what is the difference between DNA and RNA polymerase. So thank you for further videos, stay tuned with us. Thank you. Have a nice day.